if you have an allergy. All right. So let's see here, page 16. Let's talk about this a little bit. All right, what do we got? Let's go around the room. Katie, amplitude.
2.
2. The amplitude is always from that equilibrium to either the min or the max. 2, this is meters. Often they're centimeters. Keep going. Next. How many cycles do you see?
2.
There it is. 1, 2. Frequency. 3-word definition.
Cycles per second.
Right, cycles per second or cycles per time. So what did you actually use as your fraction?
1 cycle 4 seconds.
What'd you say?
1 cycle 4 seconds.
Sure, you could have done 1 cycle is 4 seconds. You could have done half cycle in 2 seconds. You could have done 2 cycles in 8 seconds. All of them, so 1 cycle in 4 seconds, all of them will come out to 0.25 hertz, no matter which way you did it. Right? Next, the period. You could, of course, invert that, but I would rather you internalize in your head.
Oh, I need 1 over L. So I got 1 over 0.25 and I got 4.
Right. And what's the 3-word though?
Time per cycle.
Time per cycle, right. And so you could have just flipped this, or you could have looked this and said, oh, well, 2 seconds took half cycle, so that's 2 over 0.5. Or 4 seconds was 1 cycle. You write that way. 2 seconds over 0.5 cycles, and that still comes out to 4 seconds per cycle, no matter which way you do it. Number of wavelengths.
2.
2, we're just counting. Wavelength itself. Well, I told you something here. The horizontal distance from A to B. That means this. This horizontal distance is 1 meter. So you need your 3-word definition for wavelength. So what is it? Okay, so what do you actually use as your fraction?
4.
What's that? 4 over 1. Okay, so you went all the way over to here, right? So you went 1 to here would be 2, to here would be 3, to here would be 4. So you did 4 meters over 1 cycle. That's good. Heck, you could have done 1 meter over quarter cycle. No matter what, you get 4 meters per cycle as your wavelength. Good? All right, now, wave speed. 2 ways to look at it. The reason I gave you both is I want you to get this from d over t and also frequency times wavelength. So d over t, you can use any distance you want as long as the time coordinates with it. So what did you use? Albert? What's that? Well, what would you do for this one? Pick any distance you want. What distance you want to pick? What's that? Okay, 4 meters happens here at location E. How much time goes with that? 4 meters doesn't happen in 2 seconds. Because 2 seconds is here at point C.
Oh, we were on the other. I was looking at the
Oh, okay. So 4 meters at
other.
4 seconds would be 1 meter per second. So no matter where you look, you can put here. You can do 1 meter in 1 second. You can do 2 meters in 2 seconds. It doesn't matter. It all comes out the same. Follow? Then frequency times wavelength. What do you got? Well, frequency we know already. 0.25 hertz. Wavelength we know. Where is it? Here. 4 meters per cycle. And so you get, of course, your 1 hertz meter, 1 meter per second. Doesn't matter. You get the same answer either way. Phasing. Back to the start. 2 points in phase.
A and E.
A and E. Sure. Anybody have another 2 that are not along the axis?
B now.
Sure. They're both at the crest. 90 degrees out. Bobo.
A and B.
Sure. A, B. Any 2 that are right next to each other? 180.
A and C.
AC. Do we have another that's not on the axis?
Oh, B and D.
Sure. And finally 270. All right, A and D. Now if you look down here, it is essentially the same process. Essentially the same thing. Would that be a spring break? So We'll just run them through right here and you see how you did. The displacement here from equilibrium, this was 5. It's still 2 cycles. The frequency, cycles per time. Well, they told you to go from A to C. Took 1 second. Notice you can't read it directly off the axis because it's a distance axis. So the frequency, cycles per time. If you look at this one, you're getting half cycle in that 1 second. Half hertz. Period, time per cycle. Of course, you could just invert this from the reference table. Or you can say, oh, well, it's 1 second per half cycle, which gives you 2 seconds per cycle. Number of waves, you count them again as 2. Wavelength, distance per cycle. You can use anything you want, but they gave you 2 meters right here. That's 2 meters per half cycle, which is a wavelength of 4 meters per cycle. Speed is the same thing as we did earlier, v over t. You can do right here. This spot is 2 meters away, and it took 1 second. There's your speed, or frequency times wavelength, 0.5 hertz times 4. Give you your 2, I'll call it hertz meters this time. Phasing is the same thing as above. You can get the same answers or switch it around. Good. From this, you can do W85. W85 is homework due Monday. W85.